Okay, so we're going to be solving absolute value equations by graphing. Now, this isn't necessarily ideal, but if you struggle solving absolute value equations, you can apply a concept that you've learned about quadratic equations and how you can solve them by graphing. So we can apply this. So the steps, we're first going to set the equation equal to 0. You're going to replace equals 0 with y equals, and you're going to graph and find the x-intercepts. So the x-intercepts are actually the solutions. So because of that, here's what you can have. There are 3 types of solutions. All right, so you can have one solution, because if there's one x-intercept, you could have 2 solutions if there's 2 x-intercepts, or you could actually have no solutions if there are no x-intercepts. So you can, like I said, actually apply this to this idea from quadratic equations to absolute value. And it's going to feel weird at certain times, but that's perfectly okay. So let's take a look at number 1. We have the absolute value of negative 4x minus 2 equals 18. Every ounce of your body is going to say, hey, let's just solve it. But there's a lot of different steps to that. All right. If we're going to solve by graphing, the first thing we have to do is we have to set this thing equal to 0. So that means this 18 right here needs to 0 out. Well, that 18 is a positive. So in order to get it to 0 out, we need to make it a minus. But what you do to one side of the equation, you have to do to the other. Now I'm going to draw my balance line here. Now here's what's going to feel really weird, and you've got to resist the urge to do. A lot of you are going to want to say, well, negative 2 minus 18, but you can't do that because of the absolute value. The absolute value is a math operation, so you can't do anything inside of it. So all you're going to do is bring it down and literally tack on that minus 18 on the end, and then 18 minus 18 here is 0. All right, so you're going to leave it like that. As much as you want to sit there and try to combine like terms or distribute or do anything, no, we're not going to do any of that stuff. You set it equal to 0, and whatever you do math-wise, you just kind of put it at the end of the inequality. Okay, so now when we do that, we're going to replace the equals 0 with a y equals. So we're actually going to physically graph on Desmos y equals, or any graphing calculator, y equals negative 4x minus 2 minus 18. So you're going to leave off, we're replacing the equals 0 with y equals. Okay, so now we go to the Desmos calculator and do that. All right, so we have y equals your absolute value. It's kind of hard to see, but it's right there. The absolute value of negative 4x minus 2. Oops, and it went outside that. Got to make sure I stay in there. All right, and we expect a V shape with absolute value, minus 18. All right, so I've got that. I'm actually going to zoom out so I can see what's going on. I know we're used to graphing with key features. We're not worried about that at all. What we're worried about are those 2 points right there. Those x-intercepts, negative 5 and 4, those are the solutions to your absolute value equation. So negative 5 and 4, so we have 2 solutions. And that's your answer. Literally all you've got to do. Oops. All right, so let's try another one. Oh. All right. That's great. All right, so here we have another one. The absolute value of 5x plus 1 equals 0. So here's the good news. This one is already set equal to 0. Because it's already set equal to 0, we can actually go ahead and replace the 0 equals with a y equals. So y equals the absolute value of 5x plus 1. Okay, already set equal to 0 there. So I'm going to graph the y equals the absolute value of 5x plus 1. So let's do that. All right, equals the absolute value of 5x minus 1. Oh, it was plus 1. Sorry about that. All right. So I hit the home button there to get me back to the home. And you can zoom in by hitting this plus. All right. So I'm looking for the x-intercepts. I've only got one x-intercept, negative 0.2. That's it. Because I've only got one x-intercept, that's my only answer. That's our only answer. X equals negative 0.2. And that's what we have. So that's an example. The last one had 2. I have no idea why I put 0.5. X equals negative 0.2. The last one had 2 solutions where this one just had the 1. If you ever get a decimal, just round. That's no big deal. All right. One more here. Number 3. We have the absolute value of 3x plus 4 equals 0. Again, another nice one for us. And it's nice because it's already set equal to 0. So I just have to replace the equals 0 with a y equals. Absolute value of 3x plus 4. And now I'm going to graph it. Y equals the absolute value of 3x. Then outside of the absolute value, it had plus 4. All right, now I'm going to move my screen a little bit in order to see it there. Or if I hit home, I'll probably be able to see it. All right, so I have a vertex, but I have no x-intercepts. That graph does not cross the x-axis in any way, shape, or form. So what does that mean? That means that we have no solution. All right, so since there's no x-intercepts, we have no solution. So really, honestly, just like quadratics, except now you're dealing with a V-shape. Same concept, same idea, nothing different in terms of that. The weird part is setting these things equal to 0, all right? And that's the last one we're going to graph. But the weird part, when you get weird ones that look like this, all right, so let's say you have something like the absolute value of 2x plus 1 minus 3 equals 17. All right, to set this thing equal to 0, how do we zero out 17? Okay, well, we zero it out by subtracting 17 from both sides. Now, this one you'll notice that you do have this minus 3. You do have like terms. You actually have 2 options in this case. I cannot go inside that absolute value, okay? I cannot, this has to stay the way it is. That cannot change. But we do have like terms right here. If you want to combine like terms, you can. All right, what I mean by that is you can have the absolute value of 2x plus 1, negative 3 minus 17 is negative 20 equals, and right here 17 minus 17 is 0. So you could do that. You can do that just fine. Or you could just leave it the way it is. And here's what I mean by that. You can just put minus 3 and then minus 17 equals 0. You can leave it just like that and plug that in. Again, you replace that 0 with a y equals. And regardless of what you do, you're going to get the same answer. Now, I said I wasn't going to graph, but let me show you that you're going to get the same answer just so there's no confusion. I'll pause it and I'll show you the graphs. All right, so here's the graph, and I have to zoom out to see the answers here and here. I've only graphed one of them. I graphed the one where I combine like terms. Now watch what happens when I graph the one that I didn't combine like terms. A lot of you are going to want to because it feels better, but I guess my point is you don't necessarily have to, and you'll still get yourself the same answer. So one of them the other one was minus 3 minus 17. And if you'll look, that's the green graph, and it's right over top the blue one. All right. So if I had that green graph, I just did, that's the first one. And if I bring that green graph back, it's right on top of it. So both give you the same exact answers, negative 10 and a half and 9 and a half, and that's your solution. 10 and a half, negative 9 and a half. All right, so if you had weird ones like that, I mean, that's what you can do. It's up to you if you want to combine the like terms or not. But again, you'll still get the same answer regardless.